Hello students, this is the last lesson of topic 1, right, which is about mathematical induction. This mathematical induction is not difficult. There are fixed 3 steps. Step 1, first let me explain to you what is this topic. Proof by mathematical induction. Proof should be incorporated throughout the course where appropriate. Mathematical induction links specifically to a wide variety of topics. Okay. For example, complex numbers, differentiation, sum of sequences and divisibility. We are going to touch most of the topics which are discussed here, right? Proof by contradiction also has to be considered. Okay, so look here, what is mathematical induction? Mathematical induction, 1 minute, mathematical induction has 3 steps. Okay, step 1 will be to prove the statement when n is equal to 0 or n is equal to 1. I mean the initial condition, which will be very easy. The second step is inductive method. We will use inductive method, and by inductive method we will prove it to be true for p is equal to k. P of k, I mean, will be true. We will suppose it. And the last step is only the important step, which you have to show that p of k plus 1 also holds, okay, or is true. That you have to show. To show this, you will have to use p of k and do changes in it, and then you can very easily prove it. Okay, then. The principle of mathematical induction, proposition notation, we use p of n. Okay, some books write pn, some books write p of n. So pn or p of n. Okay, I will better prefer this p of n to represent a proposition which is defined for every integer n, where n is greater than or equal to a. A may be 1, a may be 0, and so on. For example, in case of example 1, our proposition Pn is 1 upon 1 times 2, 1 upon 2 times 3, 1 upon 3 times 4, and so on. 1 times n into n plus 1 should be equal to n upon n plus 1. This we have to prove. So in p of 1, what we will do? We will take only the initial thing. So p of 1, 1 by 2, which will be, when you substitute here, that will be 1 upon 1 plus 1, which will also be 2. So this will be true. Then p of 2 is 1 upon 1 into 2 plus 1 upon 2 into 3. So the first 2 steps, which will be 2 by 3. P of k will be first k steps, and it should be equal to this, right? So that is just an explanation. Let us solve the actual questions, right? Okay. The principle of mathematical induction constitutes a formal proof that a particular proposition is true. Suppose p of n is a proposition which is defined for every integer n greater than or equal to a, where a belongs to z. Most of the time we are going to use it only for integers, okay? If p of a is true, p of a is true means for the initial value. A is the initial value here. N greater than or equal to a means the first value of n is a. So if p of n is true, mean initial value is true, the first value is true, and p of k plus 1 is true, wherever p of k is true, then p of n is true. I mean, as I told you, we will first prove it for, look here, suppose 1 plus 2 plus 3 plus so on plus n should be equal to, let me show you one example. Sum of the counting numbers 1 plus 2 plus 3 plus so on plus n is equal to n into n plus 1 upon 2. Okay, this is the sum for n greater than or equal to 1. So the initial value is 1. What we are going to do, we will take p of n as this statement 1 plus 2 plus 3 plus so on plus n n into n plus 1 upon 2, where n greater than 1 and n belongs to z. Then our first step will be p of 1, means n is equal to 1, so which is 1 here, and which will be equal to 1 into 1 plus 1 divided by 2. So 2 by 2 is equal to 1. So therefore p of 1 holds, right? Like that you are going to write. Then second step is let p of k be true. So when it is true, we are going to write this as 1 plus 2 plus 3 plus so on plus k is equal to k into k plus 1 over 2. Now third step is for n is equal to k plus 1, always we are going to use this one, okay. 1 plus 2 plus 3 plus so on plus k plus 1. Now we know that from here to here the sum is k into k plus 1 by 2 and plus the remaining term is k plus 1. Now taking LCM as 2, what we are going to show? The sum should be equal to k plus 1 into k plus 2 upon 2, okay. So k into k plus 1 plus 2 into k plus 1, okay. From this, let me show you here itself. I will show you up this one. So k plus 1 can be common from this, right? When we take k plus 1 common, so it will become k plus 1 and the remaining factor will be k plus 2 divided by 2. So therefore p of k plus 1 holds. Now when this holds, we will say that this statement is true, right? Okay, let us start the exercise. That was just an example. Now this question says, this is from the textbook, prove that 3 raised to n plus 1 is divisible by 2 for all integers n greater than or equal to 0 by using the binomial expansion of 1 plus 2 to the power n, the principle of mathematical induction, right? Okay, this question is from the textbook, okay. Prove that 3 to the power n plus 1 is divisible by 2 for all integers n greater than or equal to 0 by using the binomial expansion of 1 plus 2 bracket to the power n and the principle of mathematical induction. So by two ways we have to prove this, okay. So first one is by binomial expansion, right? Okay, so let us see by binomial expansion how we can solve this one. So I will start with part A. Now look here, as I told you, the initial condition has to be considered first. So n greater than or equal to 0. So what is initial value of n? 0, right? So I will start with the initial value. If n is equal to 0, right? So 3 to the power n plus 1 will become 3 to the power 0 plus 1, which will be 1 plus 1 means 2, okay, which is divisible by 2, isn't it? Right? Now for n greater than 0, okay, what we will do? We will use the binomial expansion. So 3 to the power n plus 1 we will write as 3, means we can write 3 as 1 plus 2 to the power n and plus 1 we will keep aside. So look here, this 3 to the power n I am writing 1 plus 2 to the power n. It is one and the same thing, right? Now this I will expand 1 plus 2 to the power n by using binomial expansion. You already know about it. So this will be 1 plus nc1 2 to the power 1 plus nc2, right, 2 to the power 2 plus nc3 2 to the power 3, and the last term will be ncn 2 to the power n. This is expansion of the bracket, and plus 1 will remain out. Okay. Now from this ncn is 1, and 2 to the power n also. What we will do, see this one, look here, this one and this one we will combine together, so it will be 2, right? So nc1 2 to the power 1, nc2 2 to the power 2, nc3 2 to the power 3, plus so on, ncn 2 to the power n, and plus 2. Okay. Now 2 we can take common from everywhere, so we are left with nc1 plus nc2 into 2 plus nc3 into 2 square plus so on, ncn into 2 to the power n minus 1. 1 power of n will be less from each term, and plus 1 the last value because of 2. This because of 2 we are going to write 1. Now look here, the bracket is an integer because all the integers are added, and 2 is a common factor here, 2 is a common factor, so therefore it is divisible by 2. So which is divisible by 2. Okay. Okay, so therefore we say 3 to the power n plus 1 is divisible by 2 for all n greater than or equal to 0 where n belongs to z. N is an integer. Now second part says the principle of mathematical induction. So we have to use the principle of mathematical induction. So B part, using principle of mathematical induction. Using principle of mathematical induction, what we have to do, we have to assign it some p of n, okay, for the whole statement. So let p of n is 3 raised to n plus 1 is divisible by 2 for all n greater than or equal to 0 where n belongs to z. Right. Now first step, as I said, if n is equal to 0, because initial value is 0, okay, so 3 to the power 0 plus 1 will be 2, right? Okay, so therefore p of 0 holds. Now second step, okay, second step is if p of k is true, okay, then what we can write, 3 to the power k plus 1 is equal to 2 into a, sum a, where a is an integer. So this shows that it is divisible by 2, because 2 times some integer means it will be divisible by 2, right? Now we go to the third step. Now for n is equal to k plus 1, right, we will write 3 to the power k plus 1 plus 1. From where? From this one. From this one, this statement we are writing 3 to the power n plus 1, we are writing 3 to the power k plus 1, okay, plus 1. right? Okay, and this will be equal to 3 to the power k into 3 plus 1, right? I have separated 3 from it. So now 3 can be common from this, okay? Now 3 to the power k, we can use the second step, inductive hypothesis, right? So that will become 2a, right? So 3 into 2a, okay? 3 into 2a, what I want to write, 3 to the power k plus 1 is 2a, but there was no 3 to the power k plus 1, so 2a I will write but minus 1 because that was not given with this. Therefore I am writing like this using inductive hypothesis. Inductive hypothesis, in short I am writing like this from step 2, right? Now open the bracket, 6a minus 3 plus 1 will be 6a minus 2. 2 can be common factor from this, so 3a minus 1. Now 2 into any integer where 3a minus 1 belongs to z, it is an integer, right? As a belongs to z. Okay, so therefore p of k plus 1 holds, right? 3 to the power k plus 1 is divisible by 2. Hence p of k plus 1 holds. Okay, so right, since p of 0 is true, and p of k plus 1 is true, right? Whenever p of k is true or p of k holds, whatever you want to write. Therefore p of n is true for n greater than or equal to 0, n belongs to z. So like this we have completed the proof of this whole question, right? Okay. Next one, we have past paper questions. I have chosen some past paper question because there is nothing in this chapter, the same steps we are going to use. So some past paper questions we will do here, right? Okay. So this question says, using the principle of mathematical induction, prove that n into n square plus 5 is divisible by 6 for all integers n greater than or equal to 1. Okay. Now look here. To write the whole thing like this, we will make a short form of that statement. So we will define a notation. What notation we will define? For m n belongs to z, m slash n means m divides n, or n is divisible by m. Okay, like this we have made the short form instead of writing the whole statement. Okay, so now let p of n is 6 slash n into n square plus 5 for all n greater than or equal to 1. What is the meaning of this? That n into n square plus 5 is divisible by 6. Okay, so using method of mathematical induction, Now look here, it starts with 1, so therefore P of 1, step 1, n is equal to 1 implies 1 into 1 square plus 5, which will be 6. Okay, so and we know that 6 is divisible by 6, right? So therefore 6 divisible by 6, so therefore P of 1 holds. Okay, means it is true, right? Now step 2, let P of k holds. Okay, for k greater than or equal to 1. Therefore, instead of n, we will use k. So 6 slash k into k square plus 5, k into k square plus 5, okay, for k greater than or equal to 1. Means k into k square plus 5 is divisible by 6. That is the meaning of P of k. Now third step we will take for n is equal to k plus 1. We will write the right hand side of it. So k plus 1 into k plus 1 bracket square plus 5 this is equal to k plus 1 into, okay, we will simplify this, k plus 1 bracket square we can open, k square plus 2k plus 1 plus 5, so which will be k plus 1 into second bracket k square plus 5. I am separating k square plus 5 so that I can use the statement, and plus 2k plus 1 I will write separate. Okay, now 2k plus 1, now I can open the bracket with this one, by k I will multiply both this and this and write, then by 1 I will multiply both and write. Okay, so k plus 1 into k square plus 5 plus k plus 1 into 2k plus 1, right? Now what can I do? K into k plus 1, yeah, k plus 5, I am writing it with this, right? And I am separating the other part. So when I am separating the other part, look here, k into k plus 1, 1 minute, here k plus 1 into 2k plus 1. So when I simplify the second term, it will be 2k square plus 2k and 1k, 3k plus 2 plus 1. Okay, this is like that, 3k square plus 3k plus 1, right? It will be like that. Now from these, now look here, okay, By k I will open this and this, right, and by 1 also I will multiply this and this. Okay, so I am going to write k into k square plus 5 plus k into 2k plus 1, and then by 1 also I will open. So by 1 when I open, it will remain k square plus 5 plus 2k plus 1, the whole thing, right? Okay, so now k into k square plus 5 plus this is 2k square plus k square plus 2k plus 6, right? So this and this together will make 6. Okay, so k into k square plus 5 plus another bracket 2k 3k square, because 2k and k is 3k square, here 2k and k square 3k square, 2k and k is 3k plus 6. From all of them 3 is common. Let me rewrite it here. K into k square plus 5 plus, now 3 I will take common, so k square plus k plus 2. Okay, I hope you understood this. So which will be k into k square plus 5 plus 3 into, from these two k can be common, so k plus 1 plus 2, right? We can write it like this. I will give it number 2. Okay, since k or k plus 1 is even, so from into either k or k plus 1 is even, right? We are talking about which one? About this k or k plus 1 will be even, right, here. So even plus 2 will be some even number multiplied by 3 will be 6, and therefore it will be divisible by 2. So therefore k into k plus 1 is divisible by 2. Now this is divisible by 2, this is also divisible by 2, so the whole thing is divisible by 6, isn't it? We can write like that. So hence the same thing we will write like this: 2 slash k into k plus 1 k into k plus 1 plus 2, right? So this is divisible by 2, right? Now multiply both sides by 3, so 6 is here 3 into k plus 1 plus 2, right? So which means by inductive hypothesis, right? We know this. Okay, so by inductive hypothesis 6, and from this k plus 1 can be out, k plus 1 into k plus 1 bracket is square plus 5. Okay, why we are writing like this? See here what we wrote. We wrote about this one, that it is divisible by 6. This is already divisible by 6. We already have proved it in inductive hypothesis. So both of them are divisible by 6, right? So therefore P of k plus 1 holds. Okay, so which means P of 1 holds for n greater than or equal to 1. P of k holds for k greater than or equal to 1 implies p of k plus 1 holds. Hence, by mathematical induction, p of k plus 1 holds. So, by this one, p of n holds for n greater than or equal to 1, n belongs to z plus, right? So, like this we have completed the proof of this. Now, next question says, if f of x is x minus 1 into e raised to x by 3 for x belongs to R, find f dash of x. This is easy part, let us find that. F of x I will write first. So, I will use u and v, right? This is u, this is v. So, how do we write the product rule? U dash v plus u v dash, right? So, f dash of x, u dash, derivative of x is 1, e raised to as it is, plus now u as it is means x minus 1 as it is, e raised to will remain e raised to, but into the derivative of the power is 1 by 3, right? So, therefore, this becomes e raised to x by 3 into bracket 1 plus x minus 1 by 3. 3 is the LCM, so this will be 3 minus 1 2. So, x plus 2 by 3 into e raised to x by 3. Okay. So, this we have shown the derivative of f of x, right? Okay. Now, next part, B part, prove by mathematical induction that dn of f over dx to the power n means nth derivative of f is given by 3n plus x minus 1 over 3 to the power n for e raised to x by 3 for all n belongs to z. Okay. So, we will first define this statement. So, let p of n be the given statement. We will take as p of n okay, for all n belongs to z plus. It means positive integers. Okay. So, positive integers start with 1, 0 is not neither positive nor negative. So, therefore, our first step will be for n is equal to 1 df by dx, right? First derivative df by dx. We already have first derivative, so we will write that it is here x plus 2 by 3, right? X plus 2 by 3 into e raised to x by 3, right? X plus 2 by 3 e raised to x by 3, right? This is the answer. Okay. Now, p of 1. So, dn says like this, look here. Now, in this n is 1, this we can write like this, 3 into 1 plus x minus 1 we can write like this. Okay. Why? Because this x, this 2 we can write as 3 into 1 minus 1, that will be same as 2, right? 3 into 1 minus 1 here. So, that becomes 2, which we already have. 2 is same as 3 into 1 minus 1, right? Okay. So, therefore, p of 1 holds. Now second step is P of k, we will assume let P of k holds for all k belongs to z plus, right. So therefore dkf by dx to the power k is equal to the same thing with k we will write. Look here, in this we will write this with k only. So let me copy this there for reference. Okay, so I can write 3k plus x minus 1 over 3 to the power n into e raised to x by 3. That has not come with this, but it was there, e raised to x by 3. Okay, now third step, for n is equal to k plus 1. Okay, dk plus 1, right, dk plus 1 f by dxk plus 1 will be d by dx of dk. So dk we already have here, so that we will write inside. K I should write here. E raised to x by 3, right. So we want to find the derivative of the first derivative already. Okay, so 3 raised to k is a constant, we will take it out. So 1 upon 3 raised to k. Okay, and derivative of x, this x is 1. E raised to x by 3 we will write as it is. Second time, this we will write as it is, 3k plus x minus 1 over 3 to the power k we will write as it is. E raised to x by 3 will become into 1 by 3, right. I hope you understood this, right. Okay, now 1 upon 3k plus 1, 3k plus this and this we will take out, okay, outside. Now this will be denominator here will be this and this, so the power will get added. So 3 to the power k plus 1. Numerator will remain the same, 3 to the power k plus x minus 1, right. I hope you understood this. Okay, is equal to, now look here, in this we want to take LCM, this can be the LCM, 3 to the power k plus 1 we will take as LCM, and 1 upon, now look here, there was 3 to the power k, 1 power was not there, so by that 1 power we will multiply, means 3 will be there, plus the second part remains as it is, 3k plus x minus 1, e raised to x by 3 will remain as it is. Now we can simplify numbers, so it will be plus 2, right. Okay, but if you look at this, 3k, 3 into k plus 1 plus x minus 1 over, it will become like this. Look here, this one is the combination of these two, right. So this is similar to the statement 2. Look here the statement 2 says like this. Okay, so we have got the same type of answer, only with k plus 1. So hence P of k plus 1 holds. So therefore P of 1 holds, P of k holds, for k greater than or equal to 1. Hence, P of k plus 1 holds. So, like this we have completed the proof, right? P of n holds for all n belongs to Z plus. Okay. Now the next part C, it says find the coordinates of any local maximum and minimum points on the graph of y is equal to f of x. Justify whether such point is a maximum or a minimum. For maxima and minima, what do you know? We take the first derivative and then we draw the sign diagram, and from that we decide whether it is maximum or minimum. So we already have differentiated f dash of x is equal to, where is f dash of x? Here is f dash of x. X plus 2, look here, this is f dash of x. X plus 2 over 3 into e raised to x by 3, right? X plus 2 over 3 into e raised to x by 3. This is the derivative. We will take it equal to 0. So f dash of x is equal to 0 will give us x plus 2 is equal to 0, because 3 denominator cannot be 0, e raised to cannot be 0. So which means x is equal to minus 2, right? This is the x coordinate, right? Now for this x coordinate we have to test whether how is the graph, right? So x here, f dash of x here, right? And because it is for positive values, so therefore there will be no negative values. There will be it will be from negative infinity to positive infinity. Negative 2 is there, right? Now let us check the sign diagram of f dash of x. On the left of negative 2, negative 1 or negative 3 we can put, right? And here 0 we can put and check the sign diagram, right? So when we put negative 3, let me write it properly. When we put negative 3 in this will be negative 3 plus 2, so negative 1, and e raised to will have always positive sign, so this is negative, right? So therefore I will write here this will have negative sign, and when I put 0 in this, in place of this, 0 plus 2 by 3, so this will be positive, right? So this will be positive. So my sign diagram will be something like this, right? So what does this tell you? The sign diagram changes from negative to positive, therefore it has minimum, right? So sign diagram of sine of f dash of x changes from negative to positive, therefore by first derivative test f has a minimum. At x is equal to minus 2, right? it has a minimum. Okay. So therefore, and the y coordinate we will find. Therefore, y is equal to f of negative 2, which will be negative 2, oh sorry, yeah. So f of x will be x minus 1. In f I have to put x minus 1. What was that f of x? Let me copy it here. Very long question it is. Yeah, this was f of x. I will put it here. So in this I am replacing x by minus 2. So minus 2 minus 1 e raised to minus 2 by 3. So it will be negative 3 e raised to negative 2 by 3 is the y coordinate. So therefore a negative 2 negative 3 e raised to minus 2 by 3 is a minimum point on y is equal to f of x, right? Yeah, this is a minimum point, right? So next part, D part, I think, did I copy it here? Oh, D part is here. Okay. So this page is not required. I will delete that later on. No problem. Now D part says find the coordinates of any point of inflection on the graph of y is equal to f of x. Justify whether such a point is a point of inflection. Look here. Point of inflection will have this type of the concavity should change. Look here. We know that when you have like this point, it is concave down here, on the left of A, on the right of A, concave up, either like this or like this, concave down, concave up. So such points are called points of inflection, right? There can be stationary point of inflection also, but these are just the points of inflection. If it is a stationary point of inflection, it should be something like this. At that point, the gradient should be 0. So concave down, concave up, this can be the C point, or it can be like this also, here, D point, concave up, concave down. All these points are points of inflection, right? So we'll check the concavity, okay? Now for the concavity, we need to find the second derivative. We already have the first derivative, so let me write the first derivative. F dash of x, x plus 2 over 3 e raised to x by 3. This is the first derivative, right? Yeah, x plus 2 by 3 e raised to x by 3. Therefore, second derivative will be d2f by dt square. Dx square, sorry, why I am telling dt square. Now this derivative will be u into v. We have to use the product rule here, right? So by product rule, u dash means 1 by 3 e raised to x by 3 plus, now x plus 2 by 3 will be as it is, into e raised to x by 3, and derivative of the power will be 1 by 3. Okay. So finally this will be 3 square is the LCM here. So by 1 3 we will multiply to this, okay, in the numerator. So this will be 3 plus I want to take e raised to x by 3 out plus x plus 2, right? It is like that, okay. 3 into 2, yeah, 3, that 3 will be there, okay. Or what we can do is we can substitute this into the given dnf by dx to the power n. There also you can substitute this. See, I will copy that also here, so that n can be replaced by 2 and you can get that answer also. Here is dnf by in that also you can substitute and get the second derivative, okay. So either by using this one or by differentiating the first derivative, any one method you can use and get it. To use the nth derivative, replace n by 2 here, so 3 into 2, okay. Let me write it here, d2f by dx square will be 3 into 2 plus x minus 1 over 3 square e raised to x by 3. So see, you can understand it actually the same answer, 6 minus 1 5, so x plus 5 by 3 square e raised to x by 3, okay. So either method you can use and get the second derivative. Now for concavity, to check the concavity, we will take it equal to 0. So d2f by dx square is equal to 0 will give you x plus 5 is equal to 0. So x is equal to minus 5, right? Now at this we are going to check the concavity. So at least, so there is at most a point of inflection, because when second derivative is 0 we can say that this is an inflection, but we will check that, okay, by using concavity. Using concavity test, so x and f double dash of x, the sign of f double dash of x, negative infinity to positive infinity. What is the value here? Minus 5. And second derivative, of course, we are going to check. So I will copy again the second derivative there. This was our second derivative, d2f by dx square for your reference I am copying it here, right? This is the second derivative, I am putting it here in front of you. Now we will substitute any value, negative 6, okay, on the left of it. So when we replace here negative 6, it will be negative, right? Because e raised to cannot be negative, so this is negative. So negative means concave down. And second time we can put here 0 on the right side. So when we put 0, it will be positive 5 over 3 square, so positive. So positive means it is concave up, right? So therefore the concavity changes from concave down to concave up, right? So graph of y is equal to f of x changes concavity from down, okay, downwards to upwards. From downwards to upwards at x is equal to minus 5. Yes, it changes concavity from downwards to upwards. Therefore, f has an inflection at x is equal to minus 5, and for that we will find the y coordinate. So y is equal to f of minus 5. F of 5 was written here somewhere, we wrote, yeah, this is f of 5. I will paste here again. Okay, so in this I will put minus 5 minus 1 e raised to minus 5 by 3, which will be minus 6 e raised to minus 5 by 3. Okay, so therefore this is the second point. B minus 5 minus 6 e raised to minus 5 by 3 is an inflection point. Right. Okay. Next part, E part says, this is a long question. Hence, sketch the graph of y is equal to f of x, indicating clearly the points found in part C and D and any intercepts with the excess. Okay. Now for the intercepts, what we will do? For intercepts, f of x is equal to 0 we will put. Okay, so which will make this f x minus 1 e raised to x by 3 equal to 0. E raised to cannot be 0, so x is equal to 1. So x intercept is 1. Okay, so therefore C 1 0 is x intercept, right? In the same way for y intercept, now x is equal to 0 gives, in the same thing we are going to put that equal to 0, where I had copied it, yeah, this one, x 0 when I substitute. So f of 0 will be from this, look here, in this I am putting x 0. So 0 minus 1 e raised to 0 by 3, e raised to 0 by 3 will be 1, so minus 1. So therefore d 0 minus 1 is y intercept, right? Okay, now also we can confirm the concavity, I mean the inflection point also. Limit x tends to negative infinity of f of x will give me limit x tends to negative infinity of x minus 1 e raised to x by 3. When we substitute negative infinity in place of this, okay, so negative infinity will make it 0, so is equal to 0, and when we substitute limit x tends to positive infinity in f of x, limit x tends to positive infinity, x minus 1 e raised to x by 3 will become infinity. Okay, so our graph will extend from 0 to positive infinity, right? So including all these points. So now, but this means what? When we take x tends to negative infinity and we get 0, so x axis is horizontal asymptote, isn't it? Because x tends to negative infinity makes it 0 and x tends to positive infinity makes it infinite. So upwards it will be infinite, and when we go downwards it will not go anywhere on the left, but there will be an horizontal asymptote. Okay, so therefore x axis is horizontal asymptote of y is equal to f of x. Therefore indicating or showing all 4 points A, B, C, D, the sketch of y is equal to f of x will be, look here we will draw the sketch, x axis, right? This is y axis, origin in the middle. Okay, now I will mark some points here, positive 4, negative 4, positive 4, negative 4, just for my locations. I want to decide the locations. Okay, this can be further extended, negative 8, because on the negative side we want to show more part of the graph, right? So look here, we have all the 4 points A, B, C, D. So let us first mark the intercepts. C is 1, 0, right? So C will be somewhere here, C. Okay, let me put them here, A, B, C is 1, 0, and D was 0 minus 1. So D will be somewhere here, D. Okay, A and B, let me put them here together. B is minus 5 and minus 6 e raised to minus 5 by 3, right? And A was, first point A was the minimum point, I think. Where is that point A? Point A is here, negative 2 and negative 3, and let me copy this point. Okay, I will put it here together so that we can draw the graph. I will put this here, negative 2 by 3 it is. Okay, all the 4 points. So A and B. A is negative 2 and negative 3. Okay, so somewhere A is here and b is negative 5 further on the left, and negative 6 e raised to that, so it will be somewhere here, right? Yeah, negative 5, negative 6. Let me check the y coordinate, where should be the position. Negative 3 into e raised to negative 2 by 3. This is negative, see I am writing their values, negative 1.54, and the second point is negative 6 into e raised to negative 5 divided by 3, negative 1.13. Yeah, so this is B point is little up, A point is down. So therefore this is the B point. What I have drawn is of approximately okay. Now look here, this graph comes like this, and because x-axis is asymptote, so it will go like this here, it will go up. Okay, these are the 4 points through which it will pass. I hope you understood this question. It was a long question, right? Now next question, I think this will be the last question for us. Okay, this question says use De Moivre's theorem to find the value of cos of pi by 6 plus I sin of pi by 6. You know how to use the De Moivre's theorem, right? So first part we will write it here. It is very simple. Cos of pi by 6 plus I sin of pi by 6, right, to the power 12. So the power will go in and multiply inside the angle. So 12 pi by 6 plus I sin of 12 pi by 6, right? So 12 has been multiplied here. Now when we simplify this, it will be 2 pi, right? So is equal to cos of 2 pi plus I sin of 2 pi. We know that sin of 2 pi is 0, so and cos 2 pi is 1, so therefore this is 1, right? So 1 is the answer of this. Okay. Now the second part of this question says use mathematical induction to prove that cos alpha minus I sin alpha to the power n is cos n alpha minus I sin n alpha. We know that this is the property of De Moivre's theorem, right? So let P of n be cos alpha. I mean the whole statement we will write as P of n is equal to cos of n alpha minus I sin of n alpha, where n belongs to positive integers. Okay. Yeah. Now number 1, it has the same parts. Number 1, n is equal to 1. Okay, for n is equal to 1, cos of alpha minus I sin of alpha to the power 1 will remain cos alpha minus I sin alpha, and this we can write as cos of 1 into alpha minus I sin of 1 into alpha. So look here, n into alpha is like 1 into alpha, because the power was 1, here power is n. Okay, so therefore P of 1 holds. So it is true. Second part we will say let P of k holds. Okay, So therefore, if P of k holds, then what we can write? We can replace n by k. So cos alpha minus I sin alpha to the power k will be cos of k alpha plus minus sin of I sin of k alpha for any k belonging to positive integer, right? This is by induction hypothesis, right? And we'll give it number 2. Okay. Now the third part, we will check whether P of k plus 1 holds. So cos of alpha minus I sin of alpha to the power k plus 1, right? Yeah, this we can take. So what I will do, I will separate the kth power and the 1 power. And 1 power will be cos alpha minus I sin alpha, right? Okay. Now, cos alpha I will multiply with this, and I sin alpha I will multiply with this bracket separately, okay? So cos alpha minus I sin alpha to the power k into cos alpha minus the same bracket into I sin alpha, right? I sin alpha. Okay, each one of them, minus sign will be in the middle. Then when we know about k, look here, this one we know by a method of mathematical induction from step 2. This we know the value of this, so it will be cos of k alpha minus I sin of k alpha, okay, into cos alpha minus cos of k alpha, here also the same thing, I sin of k alpha into I sin alpha by 2. In step 2 we have proved this, so by step 2 we can write like that, okay? So I hope you understood this. Now we will open the bracket and simplify. Cos of k alpha into cos alpha minus I sin of k alpha into cos alpha, then minus I with this, look here, this with this will be minus cos k alpha into sin alpha, and I wrote in the beginning, and the final thing this with this, and minus will be plus. So plus I into I square sin k alpha into sin alpha cos k alpha into cos alpha, and sin of this will be negative because I square will be in minus 1, okay? These two together I will put here. So cos k alpha, so I should write here minus and minus plus it will be, okay? So cos k alpha into cos alpha plus, because minus and minus will be plus, sin k alpha into sin alpha. In the same way the other two together I will put, so minus I will be common from that, so I will underline it with another color, these two together, okay? From them minus I am taking common, so sin k alpha cos alpha, sin k alpha cos alpha plus cos k alpha sin alpha. Okay, this will be using the addition formula of trigonometric identities. So cos A cos B, look here, this is like cos A cos B plus sin A sin B, sorry, cos A cos B sin A sin B. So will be cos of A minus B, right? So cos of alpha plus cos of cos of k alpha minus alpha cos A cos B plus sin A sin B it will be, and minus I into, this is sin A cos B plus cos A sin B. This will be sin of A plus B. So sin of k alpha plus alpha, right? Here I think this was plus, so it will be minus here, otherwise I cannot get the correct answer. So this will be minus here, right? And then this will be plus here. Okay, so cos of k alpha minus I sin of k alpha plus alpha. On the next page I will further simplify it as cos of alpha I can take common, so k plus alpha, k plus 1 alpha, and minus I sin of k plus 1 alpha, right? So I took alpha common from both of them. Look here, alpha and alpha common, right? So I am getting this answer, and this answer is exactly what we wanted to have. So hence p of k plus 1 holds, right? So p of 1 holds, conclusion we will write. P of 1 holds, and P of k, and if P of k holds, okay, then P of k plus 1 holds, for all k belongs to Z plus. Hence, by mathematical induction, we conclude that P of n holds for all n positive integer, n belongs to Z positive, right? So the proof is complete now. Let us go to the next part. Let W is equal to cos alpha plus I sin alpha. Find an expression in terms of W to the power n plus W conjugate to the power n, where n belongs to Z plus, means positive integer, where W conjugate is a complex conjugate of W. Now look here, since W is given, so therefore W conjugate will be cos alpha minus I sin alpha, right? Because we changed the sign of the imaginary part. So I have changed the sign of imaginary part. It was positive here, so I have changed to negative, right? Now using De Moivre's theorem, in identity 2 of part B, right, we find that W to the power n minus W conjugate to the power n will be W to the power n, means cos alpha plus I sin alpha to the power n minus cos alpha minus I sin alpha to the power n. So by De Moivre's theorem, it will be cos n alpha plus I sin n alpha minus cos n alpha minus I sin of n alpha, right? That power goes inside. Now when we open the brackets, cos n alpha and cos n alpha will cancel. This minus and minus will be plus. So plus 2I sin n alpha, right? So this is the answer for w to the power n minus w conjugate to the power n, right? Let us give it number 3. Okay. Now next part, D part says show that w into w conjugate is equal to 1. So this part is simple. W we already have cos alpha plus I sin alpha from the previous part, into w conjugate is cos alpha minus I sin alpha. This will be like this is like a plus b, a minus b. So answer will be a square minus b square. So therefore cos square alpha minus I square sin square alpha. I square and minus will become plus, these two together. So cos square alpha plus sin square alpha, and we know that this is an identity, is equal to 1. So we have shown that this is equal to 1. Now second part of it says write down and simplify the binomial expansion of w minus w conjugate bracket q. W minus w conjugate bracket q. We know the expansion of this, right? We know how to expand this. So this will be w cube minus 3w square w conjugate plus 3w w conjugate square and minus w conjugate cube, right? Sorry, cube. Okay. So you know how to simplify this binomial expansion. Now w cube minus 3w and 1w we will write with w conjugate plus 3 w conjugate we will write together and 1 conjugate we will write outside it, okay, minus w conjugate q. Okay. Now w into w conjugate will be what? W into w conjugate we already found here. See, it is 1. Here we have found w conjugate is 1. So w cube minus 3 into w into 1 plus 3 into 1 into w conjugate minus w conjugate cube, right? Okay. So we'll move to the next page. It will be w cube minus 3w plus 3w conjugate and minus w cube conjugate, w conjugate cube. Okay. So what we have got now is w cube minus w conjugate cube, and from both of them minus 3 can be common, so w minus w conjugate. I think this was the required result. See here, they said simplify, so this is the simplified form, right? Okay, this is the simplified form. Now third part, right? Third part says hence show that sin 3 alpha is equal to 3 sin alpha minus 4 sin cube alpha. You already know about it, right? Sin 3 alpha is 3 sin alpha minus 4 sin cube alpha. We have studied this in trigonometry. So but still here we are going to use it, right? Now this is number 3, right? Substituting n is equal to 1 and n is equal to 3. In 3, we have the third part from part C. See, let me see here part C. Yeah, this is the result we have here, right? So in this result, 2i sin alpha, w to the power n minus, let me copy this there, this part. In this part we are substituting, right? So for n is equal to 1, this result, right? This result will become w minus w conjugate, okay? W minus w conjugate, and w minus w conjugate we got 2i sin n alpha, so 2 sin alpha, 2i sin alpha, because n is 1, right? And for n is equal to 3, w to the power 3 minus w conjugate to the power 3, and this result we have obtained here, w 2i from the same result, isn't it? From the same result, 2i sin 3 alpha, 2i sin 3 alpha, because the result of this we already have 2i sin n alpha, so n is 3, so therefore it will become 2i sin 3 alpha, right? Now from D2, from D second part, what we have, w cube minus w conjugate q is equal to see here, w conjugate cube is equal to I mean this result we got from w minus w conjugate cube, right? W minus w conjugate, look here, w minus w conjugate cube. Bracket cube is equal to this, right? So w minus w conjugate, we already have this result. See, this is the result we will substitute, okay? So in place of this, 2i sin alpha is equal to w cube minus w conjugate cube is this result, right? Is equal to 2i sin 3 alpha, right? Okay, and 2i sin 3 alpha minus 3 into 2, so w into, look here, 1 minute, let me, yeah, here I forgot to write this part also, minus 3 w minus w conjugate, isn't it? See, this one I am writing here, the right hand side. So w cube minus w conjugate cube is this result, so 2i sin 3 alpha minus 3 times w minus w conjugate is this result, 2i sin alpha. Now from all of them we will cancel out I, so we will be left with, 1 minute, I will copy this result there, yeah. Dots are missing here. Okay, from this I we will cancel throughout, so 2 sin alpha is equal to 2 sin 3 alpha minus 6 sin alpha, right? Okay, sin 3 alpha, but then it was the cube of this. Sorry, I forgot to write the cube of this. So 2 to the 4 to the 8. 1 minute, let me simplify this. See, this is bracket cube. I forgot to write cube. 8i cube sin cube alpha is 2i sin 3 alpha minus 6i sin alpha, right? So dividing by 2 and I cube will become I. So 2 for the 8, I sin cube, and 2 will go from here. So I sin 3 alpha minus 3 dividing by 2, 3 I sin alpha. Okay, now after simplifying, I will cancel. So 4 sin cube alpha is equal to sin 3 alpha minus 3 sin alpha. Take this there. So sin 3 alpha will be 3 sin alpha. I cube is minus I. Sorry, I forgot to write here minus sign. So minus it will be. So minus 4 sin cube alpha. This is the result they wanted from us, right? Okay. Okay. Now the last part is remaining. Hence solve 4 sin cube alpha plus 2 cos alpha minus 3 into sin alpha is equal to 0 between 0 and pi. Okay. So I will take it equal to 0. 4 sin cube alpha plus bracket 2 cos alpha minus 3 sin alpha is equal to 0, right? So I will take 3 sin alpha and minus 4 sin cube alpha there. Okay, so 2 cos alpha sin alpha, let me open the bracket first. 2 sin alpha cos alpha, when I am multiplying both of them here, see, this into this, 2 sin alpha cos alpha minus 3 sin alpha is equal to 0. So 2 sin alpha cos alpha will be sin 2 alpha. So this one I am writing as sin 2 alpha is equal to, these two things I will take to the other side, 3 sin alpha minus 4 sin cube alpha, right? Okay, and this one is sin 3 alpha, isn't it? This part is sin 3 alpha, so therefore sin 2 alpha is equal to sin 3 alpha, right? And solving equation 4, this is equation 4, we have to solve this equation. So solving equation 4 in this interval, look here, in Casio calculator there is a nice arrangement. See, I have to use solve n and I have to write this equation, sin 2 alpha is equal to sin 3 alpha, comma, of course I cannot use alpha, so I will have to use x in Casio calculator. So I will write the syntax for this, syntax, sin 2 alpha is equal to sin 3 alpha, comma, alpha, but here of course it will be x, so let me put all x, but then I will write the values of alpha there. sine 2x, sine 3x, x, and then 0 to pi. Look here, like this I will put in the calculator. Sine, my calculator should be in radian mode. So angle I will change to radian mode, and now I will use sine 2 alpha. So sine 2x is equal to sine 3x comma x comma 0 comma pi. Close the bracket. So I am going to get all the values. So using GDC, alpha is equal to, look here, if you can see in my calculator, right? So 0, then pi by 5, then 3 pi by 5, and then pi. I'll put the picture image of this screen, right? How I am typing this. Okay, so where k is 1, 3 and 5, as alpha belongs to 0 to pi, isn't it? In this interval we wanted the value. Okay, so k has become 1, 3 and 5, right? Okay, then with this we end this lesson. I hope you enjoyed it. It was very long because there were long questions from the past papers. Next lesson will be from topic 2 on functions, where we are going to cover a straight line, then concept of domain, range, function graphs, okay, then y is equal to mx plus c, all those equations, then the graph of function, then creating a sketch of the graph, then determine key features of graph. What are the key features? Okay, so I hope you liked my lesson. This is the end of lesson 5, isn't it? It was lesson, not even 5, it was, yeah, it was lesson 5. So let me correct it. It was lesson 5. So I hope you liked my lesson. If you have liked my lesson, please like, share and subscribe my YouTube channel. Okay, if you have any doubts, if you have any questions for the October exam, please ask me on my email ID. This is my email ID and this is my WhatsApp number. The link of this PDF will be there in the description of this video. Okay then, bye.